Virtual feeder segregation is actually a physical segregation. I'll say the term is a bit misleading because the solution itself is a problem. So SAIDI and SAFE, these are the two performance indicators. So you can assume that it is a kind of score that you get in your scorecard.
Do you think the virtual feeder segregation is going to be the future of feeder segregation? Hello, everyone, and welcome to the fourth episode of the Electrical Guy Power Panel, a playlist in which we invite different industry experts to talk on the different industry related topics so that you stay updated with the industry. In today's episode, we have a pleasure to have Mr. Rahul Yadav with us. Now, Rahul is the director of Nikum Energy, a company who is into the switchgear manufacturing related to the distribution components like the reclosures, sectionalizer, and other distribution related devices. Now, Rahul is an electrical engineer with more than a decade of experience in the distribution field, and with him we are going to discuss about the feeder segregation. Now, why Rahul is perfect fit for this discussion? Because Rahul works closely with the distribution industry, not only in India, but outside India as well. So he shares a lot of insights about how the feeders are arranged, what is the scorecard of for these utilities, and a lot of interesting things that you will learn about the distribution system and the feeder bifurcation. So definitely a very interesting discussion, and make sure you watch it till the end to learn maximum out of this video. And yes, if you find it useful, then give it a thumbs up so that we invite such guests for you to stay updated. Thank you and enjoy the video. So, hello everyone, and welcome to the fourth episode of the Electrical Guy Power Panel, where we have today with us Mr. Rahul Yadav, Director of Nikum Energy. Rahul, it's a privilege to have you here with us today because we did a video a couple of weeks ago where we discussed on the segregation of the feeder, and many people were interested to know more details about that. And for sure, the expertise that you have in this field will definitely bring a lot of insightful understanding, a lot of insightful learning for our viewers. So thank you for being part of this series, the Electrical Guy Power Panel. Thank you and welcome to the episode.
Thank you for having me, Gaurav. It was pleasure speaking to you for last couple of weeks, and I believe that this video could be insightful for the utility engineers as well as students who are seeking new functions or new solutions for the existing power grid.
Certainly, no doubt about that. I'm looking forward to the discussion that we are going to have because this is something new to me also, and I'm also going to learn a lot of things from you. So thank you for joining us today. So let us start. So we we'll start with the basics. Okay, we'll start by understanding what is this feeder, how it's structured naturally, what is their capacities, and things like that. So now we know from a distribution substation, it's not just one single feeder that goes and fed all the load. So there are multiple feeders that goes out of a substation. So maybe can you help us understand how these feeders are arranged generally? What is their capacities and understanding around that?
Yes. So as we speak about feeder, there is a basic voltage level we are talking about, right? Here we will mostly cover the medium voltage feeders that are on 11 kV and 33 kV. If we speak about India, going in particular, 11 kV feeders are most profound and are widely used all over networks. 33 kV feeders we mostly have for industrial loads, right?
Yeah.
Now speaking about the dynamics of a feeder, actually, if you compare three stages of electricity: generation, transmission, and distribution, you'll observe that distribution is the most dynamic form of electricity.
Yeah.
So every day the load is changing, new people are coming in, settling, new colonies are getting set up. So therefore, feeder is also very dynamic in nature. A feeder is the final link to the distribution system. Now, a feeder, it can feed an agriculture load, it can feed a industrial load, it can feed a rural or urban load, depending on the requirement. Talking about the capacity of a feeder, so essentially the capacity is limited by the sending substation or the power substation from where the feeder is derived. But usually, considering the length and the losses, the line losses, technical losses, the feeder load is can range from several kilowatts to few megawatts. I'm talking about 11 kV.
Yeah.
For 33 kV voltage level, the load can be much higher depending on the load. Another aspect that should be taken care while studying or designing feeder is the length of feeder. A feeder can be as short as few hundred meters to several kilometers. I mean, I've seen feeders running on 11 kV with a 50-kilometer length.
Oh, that's huge.
So you send 11 kV from the substation, and the consumer is
Mm.
receiving approximately in the 8 or 9 kV. So yes, it is dynamic.
So, but then you also importantly talked on a point that a feeder can have mix of loads. So it can be agricultural, residential, commercial, and it's a mix.
Correct.
And for example, let's say on one single feeder, if we reach the capacity, we reach the peak of it, then is it like we have to give a new feeder for the balance customer, or how is it?
See, the most relevant way is to increase the feeder capacity. A feeder's capacity is limited by the conductor size, first thing, what
Mhm.
size of conductor we are using. Second is the transformer capacity. So
Mm.
these are two things through which we can increase the feeder capacity or the feeder load handling capacity.
Mm.
Another way of handling increasing load is backfeeding. You can pull in another feeder, create a branch or a midpoint connection, and feed feed the load partially from another feeder. So
Mm.
there are options available based on the best solutions comes out based on the geographical conditions,
Mm. Mm.
because
Mm.
feeders are always running through the roads or the colonies.
Yeah. But clear. But when you said a
Mhm.
feeder can go as long as 50 kilometers, but you're
Right.
talking about specifically on the radial distribution or the ring main type of distribution? Any specific type of distribution that you're talking about?
Okay, this is the radial I was talking about.
Okay.
Yes.
And is it the
In
same case with the ring main distribution as well?
ring is not the same, because when we talk about ring feeders, they are mostly done in the city areas,
Yeah.
and the cities has a limited geography.
Hmm.
So usually the voltage levels are not a problem in the city, but more in the suburban or rural areas.
Yes, I think that is valid point, and it's important for our viewers to know that we are specifically talking about a distribution system which uses a radial type of distribution. It's also called as the tree distribution, where we have
Right.
one single feeder and we take a lot of branches out of it. So yeah, but that's how a radial feeder generally arranged. So thanks for that information, Rahul. Really appreciate. Now, Rahul, I want to understand when we discuss about distribution, we talk about feeders. So two concepts comes up very predominantly. One is
Right.
the SIDI, one is the SIFI. So
Right.
can you maybe talk more on that? What is these concepts and how it impacts to the utility, how it impacts to the end consumer? Can you throw some light on that?
Yeah, absolutely. So SAIDI and SAFI, these are the two performance indicators. So you can assume that it is a kind of score that you get in your scorecard.
Hmm.
Okay. Now, coming to SAIDI, SAIDI is called System Average Interruption Duration Index, and SAFI is System Average Interruption Frequency Index. The name is itself clear. SAIDI depends, or the SAIDI is derived from the duration of the interruptions, and SAFI is derived from the frequency of interruptions. Suppose you have a power outage which lasts for 30 minutes, and you have 5 power outages that last for 6 minutes. Okay.
Hmm.
The duration of the total outage is the same, but the frequency is 5 times
More.
more. Therefore, this kind of consumer has been interrupted 5 times, and the SAFE score is very poor. Okay, the SADI is the same, total 30 minutes. There is also a formula which can be through which we can calculate. SADI is simply total number of interruptions divided by total number of consumers served.
Okay.
And I'm sorry, SADI is the total minutes of interruption. We're talking about duration, right? SAFE is the total number of interruptions. So higher number, higher is the SAFE, and higher is the duration, higher is the SADI. Every utility tries to keep these numbers to minimum, and there are different solutions or different equipment which can come into action or help the utility to get a better SADI and SAFE score.
Quickly, if I have to summarize, so SAIDI is something that measures the number of duration of the interruption that has happened, and
Yes.
SAFE is something that we measure the number of times the interruption has happened.
Yes.
And if that is high, so any of the score is, for example, high for one particular feeder, then what is the impact of that on the utility? Like there are some actions taken against that, or what is the impact?
The utilities are in India, most of the utilities are government owned. There is no penalization. We can't penalize the government. But yes, they do have difficulty in receiving funds. See, ultimately, electricity is a business.
Yeah.
And whenever you want to, you want people to invest in capex, then you have to present your scorecard. So
Yeah.
that is the point. So
Understood. Now we explored about the basics. We discussed, okay, how is the general radial feeder arrangement? What is the scorecard of the utility? Now it is very important for us to understand why utility tries to segregate these feeders. So we have mix of load, as Rahul indicated, agricultural, industrial, residential, everything is mixed on one feeder. So, but then why utility tries to have segregation of those feeder? So on that topic, Rahul, allow me to ask you, the physical segregation that happens of the feeder, what are the challenges? Now we did one of the video previously where we discussed on this segregation topic, why it is important, but I want you to understand from the actual person who has handled that topic. So maybe you can you throw some light on talk on why this segregation is done first. Second, what are the actual problems faced by the utility while doing the physical segregation of the feeders?
Okay. So first, why feeder segregation is done? The primary reason is the nature of load itself. I'll explain it through an example. Suppose we have an agriculture load where we require 4 hours of electricity every day. And then we have a consumer or a house where we require 24 hours electricity every day. What happens usually is when you are giving 24 hours of electricity to an agriculture consumer, it can result in power theft or undesired use of power, which was not intended to be used in for agriculture purpose. Okay. So feeder segregation is done to manage the loads or manage the consumers basically. Now what happens is once you have done that, it creates a problem for the utility itself because the solution itself is a problem. The biggest problem is the cost. There is one geography. There is one geography, and you are drawing two lines to power the same geography. So a huge amount of capex is involved. You literally have to build two feeders for the same network, I would say. Double the money, double the network length, double the maintenance, double the cost.
Yeah.
So yes, you cannot manage your loads without feeder segregation, and it becomes very difficult to manage the network after you've done feeder segregation. Now, talking about India in particular, there is another problem of land acquisition.
Mm,
So, feeders are drawn through the fields or the private land, and people are not usually very keen to let a high
yeah.
voltage line pass through their own land. So,
Mm.
yeah, that is the major problem, I would say.
Yeah, so I think very clear. You mentioned that it takes a lot of investment first because you'll have to have dedicated equipment, dedicated conductors, poles, and a lot many things in order to maintain those two separate feeders. Maintaining that is also a challenge. You'll have to have additional maintenance staff, and the land issue, as you mentioned, they are like a very problematic solution for having this segregation. And certainly, if I'm the utility, I will not choose to do that looking at all the problems. So, yeah, very, very valid points mentioned, Rahul. Thanks for that information. But then, if not the physical segregation, if physical segregation is not the perfect solution that we are looking at,
Mhm.
what do you think about alternate solution? Do you think the virtual feeder segregation is going to be the future of feeder segregation? What is your thought on that?
Yes, virtual feeder segregation, it appears to me as a good alternative. Having said that, it should be tested at few places because India it has its own challenges. If we talk on global scenario, then I believe in most of the developed economies, there is no feeder. There are no separate feeders. So
Mm,
they plan their feeder with virtual segregation. I mean, it is a concept which is predominantly observed in India and the neighboring countries.
mhm. Understood. Then maybe
Yeah.
briefly, can you help us to understand what is actually this virtual feeder segregation? Briefly, can you talk on that?
Okay. Yeah, sure. So virtual feeder segregation is actually a physical segregation. I'll say the term is a bit
Mm,
misleading. So what happens is instead of drawing two lines or two separate feeders, you are utilizing the same feeder and you are creating connection spots or the branches. You are managing the feeder in such a manner that you can disconnect and connect separate wings of the feeder as per your requirement.
mm,
Each wing will serve a different kind of load. One wing can serve industrial load, one can serve agriculture, or one can serve a commercial load. Like that, you have more control on your feeder.
if we compare the solution that you just mentioned and the physical segregation, I believe this segregating lines using the reclosures and other equipment is far better compared to the physical segregation that we discussed, right?
Yeah, of course, it is far better because when it is done in medium voltage, the number of devices are fairly low.
Mm.
When there are fewer devices, it is easier to maintain and it is solving your purpose as well.
Yeah, yeah, clear. I think that's very valid discussion, Rahul. Thank you for that. And for our viewers, if you don't know what is this feeder segregation, why we do it, in any case, Rahul just explained. But if you want to learn more about that, we created a dedicated video talking on that. I'll put a link for it down in the description. You can go and check it out after this video. Okay, now we understood that physical feeder segregation is not something that we are looking for. It has its own problem. And as Rahul mentioned, the solution itself is a problem. So that is something that we want to avoid 100%. Uh, the concept virtual feeder segregation can be the way forward. But for that, what kind of infrastructure do we need and things like that? Now we'll understand that from Rahul. So, Rahul, my next question to you is, if I want to implement this, I am a distribution utility. I want to, utilize this virtual feeder segregation in my network. So, what kind of infrastructure, what kind of equipment, what kind of devices I need to have in order to implement this solution?
Okay, talking about infrastructure, I don't see any special requirement. The infrastructure we already have, it is ready to, I mean, it is fairly simple and it is ready for this virtual segregation. But yeah, we do need specialized devices. I'll say we need smart devices which can work autonomously based on the requirement.
Mm.
So again, I'll try to explain it with an example. We had a physical feeder. Then we had installed switches or reclosers at the connection points, okay, or the particular wings of the particular branches of the feeder, each one serving a different kind of load. Now it is desired or it is required from that device, it should be able to switch on and off the load autonomously without
Mm.
intervention of SCADA or a person physically. So having these smart, simple devices, uh, it is, I mean, these can easily make a virtual feeder bifurcation into reality.
Mm. So the major requirement, what I understood, is you have to have the smart devices which can perform the task autonomously, as you mentioned,
Correct.
and that is it basically. But I think also majorly the location of that particular device will also matter to this, right? Where you are placing that, where you are creating the branches.
Yes. Yes, it will matter.
Yeah.
So
So I think,
each,
yeah.
okay,
Please continue.
okay. So each feeder has a different geography. So it can best be decided by the user of that feeder where the device should be placed.
Mm. So I think then it's a minimal kind of investment that we're looking at if we are utilizing this solution. I mean, if we compare it with the physical segregation, then this solution is gonna give us a lot of saving in terms of the money that we will be putting in to segregate these feeders. So uh, I think it's the way forward. Then I mean, in the radial distribution, what is your thought on that?
Yes, it does save money, and more importantly, it saves time
Exactly.
because
So yeah.
I'll say building a altogether a new line, it is just
Yeah.
building a
I
new house instead of adding a room. You're building the entire house.
Yeah, exactly. That's a valid point, and I think a very good example also. So this is the right solution, then I believe. And do you have like any concrete use case for this? Like some of the utility utilize this solution and they're doing fine because you are producing all the equipment that is needed for this. So you have smart equipment in your portfolio. So do you have any concrete example where this kind of solution was utilized and it's working perfectly fine?
We do have equipment specifically for medium voltage distribution. As we were talking about reclosers, stabilizers, yes, that is our portfolio. Unfortunately, this has not been this has not been case in India. We usually the utilities they use equipment to improve SAIDI and SEFI. I'll say that virtual feeder bifurcation is not on their agenda or the focus point right now. There is a reason to that.
Mhm.
Most of the utilities in India, I'm talking about the government and particularly for the suburban and rural networks. The SAIDI fee and the distribution, it is not in a good shape. So I believe they are trying to first address the primary issue, and once done that, they can focus more on virtual feeder. But having said that, there have also been multiple projects of virtual feeder of physical feeder bifurcation
Mhm.
throughout India, throughout different states. Once you have put all the money into that, it doesn't give much room to improve. It doesn't give you much budget to improve your existing infrastructure. There, I do remember there was a pilot project in Rajasthan. It was also a PFC funded project, but the size of the project was very small to create some impact.
Mm.
Yeah. It was
Understood.
done about 4 to 5 years ago. Unless
Mhm.
we have something tangible, uh, it's difficult to say how the project performed.
Mm. Understood. Clear. But certainly it has a potential to become a better solution than the physical segregation. But thanks for all the inputs and insights, Rahul. now we are aware of the infrastructure that we need, but like many of the utilities, they have their existing infrastructure. So if I'm the utility, I'm having a huge infrastructure which is already available. So what changes, what practical things I need to change if I wish to consume this virtual feeder segregation solution? Can you guide us on that, Rahul?
Yeah. So talking about the practical steps or the process, how
Yeah.
to do virtual feeder bifurcation. See, the first thing and foremost important thing is the planning. And once you have planned things well, then comes the implementation. Second step is addressing the or studying the load pattern. Every feeder or every load has a different pattern. If you talk about industry or commercial, uh, you will have full load or 80 to 90% load at one point, and suddenly the load will drop to zero
Yeah. Mm.
or very low. On consumers, it is not like that. For agriculture, it is a different story.
Mm.
So once you study the load pattern, then you will know what is going to be my load factor in the feeder. Second, you will also understand what capacity do I need. Okay. Once you have understood it, the second part is to address it. Once you know what capacity do I need, you can either go for increasing feeder capacity or increasing the conductor size, whatever is required. The third step is creating backfeeds. Suppose
Mm.
my now it should also be understood when we are creating one feeder, then the feeder itself becomes critical. Earlier, you had different feeder for consumer, different feeder for industry. If you are unable to serve your consumer, then you are losing the revenue, and you are losing the revenue very fast. Now, when it becomes critical, then you need backfeeds. Suppose my line goes out, then how am I going to supply the line to these
Mm.
consumers? So backfeeding becomes an important feature, interconnecting feeders with each other and
Yeah.
sharing the load.
Mm.
Then finally comes installation of smart devices. You can install a pole mounted switch, or be it on medium voltage or low voltage. It depends on your convenience and how the engineer is designing the system. But yes, it should be smart and autonomous. Then lastly, you will need monitoring of the network. Okay. In India, the structuring is such that there is an engineer dedicated for a substation, and he's taking care of all the networks going out of the substation. Some utilities, they have now differentiated or bifurcated this role, where the engineer only takes care of the substation part, and for the lines you have a separate engineer dedicated to that. More or less, whoever is maintaining the system, he needs certain visibility, because uh, the network is large. Usually there could be 4, 5, 10, 12 feeders also.
Mm.
So you should be aware what is happening in my feeders. You can opt for a mini SCADA or a small scale SCADA, or you also have other open source solutions depending on the requirement of the utility. Second part of this monitoring system is a robust network. So once you have smart devices, communicable devices, you will need a network, a robust network through which can communicate. And these communication, it could be through RF, through GPRS, through fiber optic, whatever means is suitable to the consumer. We have a lot of options these days. Since the IoT came into picture, we have LoRaWAN and many other protocols or hardware, which has reduced the costs as well as created simple and reliable networks. So yeah, I think these are 4 to 5 steps through which a
Yeah.
utility can plan their virtual feeder bifurcation. Okay.
So let's summarize what Rahul just mentioned. Few steps to implement this virtual feeder segregation. Number one is to understand what is the load that is going to be on your feeder. Number two is that understanding the feeder capacity and maybe if needed, an idea on how we can increase that. Third important step that is mentioned by Rahul is backfeeding of that. So in case if the main feeder goes down, what is the backup plan that you have? So try if you can interconnect any of the feeder to that. The fourth step and very important step is where we implement the necessary smart equipment in the grid of that distribution network that we have. And the last one is importantly of monitoring those things, controlling those things. So if you
Correct.
implement that steps, then I think you will have a better distribution network. So thank you, Rahul. Thanks for sharing all the insights on that. Okay, maybe Rahul, this is the last question to you. We will not take much of your time now. So I was going through your website, okay, and I came across a product. You are calling it as Visu, and when I was reading the description of that, it is mentioned as a revolutionary innovation. So I'm interested to know what is the special about this product Visu that you have. What is that product briefly? Can you help us understand?
Yeah, sure. So Viju is a particular sexualizer. We call it Viju sexualizer. Now, the difference between the Viju and the traditional sexualizers is that I'll give you the first and most important difference is the visual indication or the visual separation. See, actually, Viju was created particularly for Indian utilities. If we talk about vacuum or SF6 insulated or interrupted devices, they are quite expensive to be afforded by the Indian utilities. So, and then the maintenance or the operation is also difficult because we have we have a different kind of staff in our utilities. So everyone is not aware how a recloser or a SF6 type load break switch works, and they might not have the required skill set to maintain or repair the equipment if it goes out. Viju, on the other hand, we try to keep it very simple in design and simple in operation. Viju addressed one challenge for the utility. The biggest challenge was the maintenance. See, now we are talking in terms of SAIDI and SAFE or feeder restoration. What happens is whenever a section of the line becomes faulty, the first step is to isolate the faulty section. It can be done via a recloser or a sexualizer, depending on the philosophy that we are using. Now, what happens once the device is opened? You do not have a visual feedback because the vacuum or the SF6 they are enclosed in a chamber, and the field maintenance staff they do not have a visual sight of
Yeah.
a clear line. Therefore, they cannot simply go and maintain the line. So what was happening is either the utility guy he was going back to substation, drawing out the VCB, or he was putting some additional disconnectors or isolators on the feeder itself.
Yeah.
That was a big problem, and it was kind of defeating the purpose for which the devices were installed.
Mm.
Yet the utility has put up a lot of money in putting the device in their network. So this is the first major challenge which you addressed because it opens up and you can clearly see the separation between the contacts.
So there is clear visible
Yeah.
disconnection of the contact so that the operator can 100% be sure, okay, it's the line is disconnected.
Right. The second problem that we observed was that uh, the staff or the operator he had a problem in operating the control unit, basically the controller or the relay, uh, or what is it is called. So to simplify that, we put up fault indicators on the high voltage switch itself.
Hmm.
So it creates a certain comfort level for the operator that only the particular phase which has fault, it will blink or it will give a visual indication to the uh, patrolling team or the maintenance personnel, so that he can only address that particular conductor.
Yeah.
So these
So
are the two
fault.
challenges that are addressed by this device.
Mhm.
And we also kept it, we also tried to build it economical so that it can be used in large networks. Talking about Viju, there is also one drastic improvement that we did. It is called the broken conductor. So what we usually observe is our networks are designed such that it will give a fault indication when there is high flow of current. And now suppose a situation where the conductor is broken and it is not grounded. It might be hanging on a tree or
Mm.
somewhere else. The current will go down, it will go off, but still the protection relay will not trigger the fault or the opening of the device because there is no flow of current. So there is a protection under NC code 46 BC. It's called broken conductor. The challenge with broken conductor was the malfunctioning of the broken conductor, which was triggered due to change in phase of sequence. What we addressed with Viju is we have created a custom logic that does not malfunction when the phase sequence is changed.
Mm.
So we are trying to give a very reliable protection for the broken conductor through Viju sexualizer basically.
Yeah, certainly it's a very interesting product, and I will encourage all our viewers to go and check out that product. I will give link for the product down in the description. Really interesting. So it combines, as Rahul mentioned, the visual indication, the fault passage indicator, and also a custom logic for the broken conductor issue. So very interesting device. Thanks for all the insights, Rahul. I think the whole discussion was really interesting. We got to learn a lot of things, the concepts about the scorecard of the utilities, distribution utilities, the problem with the physical segregation, and maybe the proposed solution like the virtual feeder segregation could be the way forward. We don't know what is the future. Maybe everybody will go and utilize that. But certainly, very interesting discussion, Rahul, today. And I thank you for your time. Thank you for being with us. It was an honor talking with you. Thank you.
Thank you, Gaurav. It was really nice talking to you. And thanks for having me.
Thank you.